let's take a look at problem of the day. Today's problem of the day is a little bit more difficult than some that we've had in the past. Not so much that it's a hard concept, it's we're going to have to work at a problem type thing in reverse using slope. So let's see, we've got a line passing through the points x and -3, and then the other point -4, 2. Both these are on the coordinate plane, so we'll look at a graph in a little bit. If the slope of the line is 2, what's the value of that x? So again, we're given 2 points. Well, sort of given 2 points. We're given 1 point. We're given a slope. And we're going to find one of the missing coordinates for that second point. So let's take a look and see how we're going to go about working this. First of all, some key stuff. Slope. We also have points. There are 2 of them. So what I'm going to think about here, I'm going to think about this being like, where it's got an x, we're going to say x1 and then y1, because that's going to be our first point up there we've talked about. And let's put, how about it, x2 and y2 right over here on this one. Now, you know, where am I going on that? Because I know the slope formula is equal to y1 minus y2. I tend to like doing that. I'm going to go ahead and do that. And then we'll have x1 minus x2. Now, it's immaterial which point you name the first or the second point because these points are on the same line. Yes. So when we put them together and get a slope formula, remember the words rise? Some of you are wondering, where'd you get those that coming up from? We don't see any x's and y's. Just from the rise and run. This is a formula. Take your y's, subtract them. Take your x's, subtract them. Remember, y's are rise, x's are the run. The good news is we've got 1, 2, 3, 4. Count them. 4 numbers ready to work with you. Work with me, work with all of us. So let's take a look and see how this is going to fit in. We're going to put 2 is equal to the slope. That was sweet. That was easy. Over here, let's do our y's. And make sure you use y's, all right, on top. Got to make the y's happen on top. We're going to have a -3 minus 2. All right, be careful on that. We're just going to give us -5 here in just a minute. Some of you are already playing ahead of me, I'm sure. Now, underneath that, we have x. And we are going to subtract a -4. Now, notice what I write. You say, Ernie, why don't you write subtract -4? Why don't you just put subtract 4? Because that's what it is. It's saying we put our x value in there, which was our first x that we have up here. And our second x is a -4. Remember, that's a subtraction between those. So very important because what's going to happen is these are going to go adding the opposite, which is going to actually give us x plus 4. If you put x minus 4, you are not going to get the right answer. It's not going to wind up where you want it to be. So let's see. Are you ready to do something? Let's make this even easier. You keep saying, Ernie, you're going to make it easier. I am. Let's go ahead and put a 1 underneath there, and we're going to make a proportion. So let me rewrite this out here a little bit where we've got a little bit of room to work with. And I'm going to go ahead and say that -3 minus 2 is going to give me -5. And underneath that, I've got this x plus 4. All right, looks nicer, doesn't it? Cleaned up a little bit. That's what arithmetic is so good for, with positives and negatives or all these good things. So let's cross multiply and see where this is going to take us. It's going to take us to, remember when we say 2 times, we want to say 2 times x plus your 4. Notice I put in parentheses because the 2 not only hits the x, it's got to hit the 4. You got to double everything down there as you run through there. It equals, on the other side, a 1 times a -5. That one's easy, -5. Distribute time, distribute. And I get 2x plus 8 equaling -5. And you say, what we're going to do, we're going to subtract 8, of course. It's just like a little equation now. And we're going to see where we go. We get 2x equaling a -13. Which by my calculations, and hopefully by yours also, you divide 13 in half, you're going to get 6.5. You say, well, Ernie, can we have that? Sure we can. Sure we can. You know, these aren't just always going to be integer values. Sometimes we think they're supposed to always be integer values, but many times you get fractions and decimals and other good things that happen there. And we're going to let this fly as a 6.5 or -6.5 or 6.5, we like to call it. 6 5/10, blah, blah, blah. There you have our x value. Now, what I want to do is, I was going to do something like this. I want to put this to a graph. So if y'all can take me off just a little bit here and let me put a sheet of graph paper up here. Thanks, guys. So we're going to show you what this looks like physically. And had it come out to an integer, it would probably have been a lot easier to do. But since we have a rational number here for our answer, that -6.5, it might have hit a little bit differently. So let's see where we are. We are going to start at -4, which means we're going to go left 2 places, and we go up 2. There's our point that we definitely know both coordinates. And according to this, we are going to be doing a, my goodness, what is it? A 2/1 slope. So let's do that. Let's go down 2/1, down 2/1. No. We want to go, yeah, that's right. You say, well, Ernie, wait. It says +2. Right. I'm going down and I'm going to the left, which makes it what? +2. So we'll make sure y'all are with me out there. And we're going to keep clicking on down there until we see what looks like a nice straight line, because it's a linear. Remember, slope has to do with a linear line, I think. So let's connect. I'm trying to make this as straight as I can. And remember, what did we say? We knew the y going with this one was what? It says -3. So we're going to go down here to -3, and we're going to cross 1, 2, 3, 4, 5, 6. Not quite 7. We're right there in the middle. There's the point. -6.5 and, let's see if we can get that in there. So -6.5 and -3. There's your coordinate. Pretty cool. You can come back and do it in that respect. And I'll tell you something. If this had been just a nice, had come out to be a nice integral value, you would have just nailed it right on these corners. But even so, it's not too far off, okay? -6.5 and -3. There's the point. And that's an easy way to check it. Does it make sense? Remember, we're on a graph, and we're just seeing where the points lie.